Hi, welcome to Teardown Tuesday. Today we're going to take a look at the Rigol DSG815 signal generator as opposed to a function generator. And if you don't know the difference, a signal generator is like a proper analog, in this case RF signal generator from 9 kilohertz to 1.5 gigahertz, whereas a function generator these days is typically, almost all of them, direct digital synthesis. They're a digital generator and actually generate the waveform with a digital to analog converter. This thing doesn't do it. It's a proper RF signal generator and has the specs to match. So we'll take a look inside. It's going to be lots of analogy RF type goodness. Beauty. And thanks to the local Australian distributor John South Adimona, who you've seen on the blog before, loaned me this little puppy for teardown, and possibly we'll have a play around with it too, but we're just doing a teardown today. And this is the 1.5 gig model, the 815. There's also the 830, which is a 3 gig bandwidth model. That, I believe, is the only difference. This one is about $2,000 US street price, which is not too bad for an RF signal generator of these sort of specs, and the 3 gig version is about $3,600 US bucks street price. So it looks all kind of funky with these big rubber surrounds on them, and very nice if you have to, if you, I was going to say if you have to drop it, if you did accidentally drop it, because it'll stop. Look, none of the RF connector and the knobs and everything don't actually protrude from the rubber, but it, which is great if it falls on its face, but otherwise, like here, you can see like the shadowing of the light and stuff like that. Not a big deal, but mate, that's just my studio lights here up on the roof behind me that are doing that. But yeah, they do protrude just a little bit too far, but you can take them off, you can unscrew them, no big deal. And we've got ourselves a nice big ass end connector. Of course, there's the low frequency output as well for modulation, because you can do all sorts of modulation and stuff like that. The keys on it are angled. Check those out. So you actually push them down. You don't push them in. I can't actually push that in. It's like down like that, which is rather interesting, a little bit disconcerting at first, but I guess I'll get used to it. And the function keys, I don't believe this is a touchscreen, they also like push out. I can't push those in. I don't know, I haven't powered this thing up yet, but if I don't go in, if I try to go in there like that, I'll push it straight on. It's weird, because you're generally used to pushing buttons straight on and your finger goes whoop off to one side. Why have they done that? I don't know. And this one up here is a normal button, so is that one, but they're trying to be fancy-pantsy and differentiate them. Not sure I like it. Well, I'll tell you what, they're not mucking around on the back. Look at what you get. You get the 10 megahertz reference out. More importantly, the 10 megahertz reference in. I'm not sure what oscillator they've got inside this thing. I don't think it's like an ovenizer or anything like that. It's probably just a TCXO. And more importantly, 10 megahertz reference in, because if you've got lab frequency reference standard, you can plug that in. We've got LXI Ethernet. We've got USB device, USB host. We've got pulse in and out, external modulation, signal valid, which is rather interesting, and trigger in. I don't know what these options here are. And as you can see, it's quite small and compact compared to a kind of equivalent one, which is my Marconi Instruments / Aeroflex 2023, which you've seen a teardown of as well. So basically very similar performance, except this one, the Marconi goes a bit lower in amplitude, well, a fair bit lower in amplitude, but the Rigol can go higher in amplitude. I think phase noises, which is one of the big specs, is quite equivalent. So, look, big difference. Anyway, enough talk. You know what we say here on the EEVBlog. Don't turn it on. Take it apart. Bloody ripper. And this is always the best part. Oh, so satisfying. Of course, we could have taken off that nicely, but nah, we're making a statement. Alright, here we go. We may not see much except a, big-ass processor board, because all the RF goodness is probably going to be inside, well, it should damn well be, inside some shielding cans. And, yeah, well, that's boring as bat poo, isn't it? Although I tell you what, I don't mind it. It's nice and neat and tidy, isn't it? What are all these? There's obviously some posts in here for some option boards or something else, but look, heat shrink on the coaxes here. Very, very nice attention to detail. They've tied them down. They're not flapping around in the breeze. Very nice. Here's our power supply. It's nice and shielded. Once again, they've attention to detail. They've tied down the cable up here so that when you slide on the case, the wires don't get pinched. Just, you know, it really is quite nice. Fan airflow wise, we've got vents on the side here. The fan actually pushes out this way, so it's sucking all the air in through the vents on this side over the block, because any of the RF stuff that gets hot is basically going to be radiated from the internal block, and you can see the big ass block down there. So that's the fun stuff that we want to take a look at, and let's have a look on the bottom. Whoa. Whoa. Now, one of the first things I noticed, we'll check out the rest of this in a minute, and of course we'll take off the die-cast metal can, but check it out, we have a little option module. There it is, OCXO. That's an oven-controlled crystal oscillator, so that's nice. Look, they've got like a card edge directly onto the board here, going right into the RF shield. That is fantastic. I really like that, and that's what that option is in the back. Just plug it in. Very nice design. Thumbs up. And we've got ourselves some PCB mount coaxial connectors right on the board, coming right out of the shield. That is absolutely brilliant. Obviously designed to go through this cutout with folded metal there. Very nice attention to detail so that you don't cut your wires on the potentially sharp edge there. What they're for, I don't know. Some option board on the top. I don't know. I should have actually researched this before I started tearing it down. Anyway, you can see the center line of the PCB in there, and they've got the gold plating on the edges of the board too. So very nice attention to detail, so nothing escapes from this metal can. Fantastic. And all this stuff outside here, obviously power supply. These are all going to be, I don't even have to look at them, they're probably 1117 low dropout regulators. More regulators up here. Everything's going to be linear, none of this switch mode rubbish. So it looks like we have our power coming over here. That would come from a switch mode power supply. It's how they get the size down, of course, but you won't find any switch mode converters on the main analog board itself, either outside the can or inside the can, definitely. Okay, looking at the spec sheet, there seems to be a pulse modulation option, so I'm going to assume that that will fit in here, having the RF coaxes coming up here, so that'd be the modulation, pulse modulation output, and digital control cable probably coming up here to the board. And let's pop the front panel off here. Took off the rubber baby buggy bumpers there, and 4 screws here. Oh, another nice design. Look at this. There you go. PCI card edge connector. Oh, thumbs up. Look at that. Beautifully modular, and the RF coming straight out of the brick. Beauty. And I'm not even going to bother tearing that down, because that's not what we're here for today. We're here for the RF can magic. And the power supply looks very nice. They're doing everything right. Look at that. It's beautifully laid out. They've got protection. They've got a decent amount of input filtering and stuff like that. Very nicely spaced. Airflow, you know, some Celastic to hold stuff down. Everything looks hunky-dory until... Capson brand. Ugh. Why? Like, this is not a bottom of the... I know they're trying to make a cheap-ish RF SIG-Gen, like, you know, performance for the price, but come on, you don't have to use caps on bloody caps. At least they're consistent all the way through. I'll give them that. And eagle-eyed viewers may have gone, hey, Dave, what's going on here with this earth pin? It's just flapping around in the breeze. Well, no, it's not. It's actually a right angle PCB mount job like that, and yes, it does actually go through the traces right down, so no problems. And one thing I noticed, these little red permanent marker marks here, noting that for all the screws and things like that, not only for all the screws, but have a look at the chassis. Somebody's marked it off there, and I see this all the way around this thing, the production operators either, conscientious or it's part of their procedure when they assemble it to actually mark off with red every screw and every cable tie and everything that they've put in. Even the connectors. I mean, look, you get it on the connectors as well. Yep, I've plugged that in. I've made sure that's okay. Or is that somebody else as a separate step coming around and checking it? Either way, I'm impressed. Now, we could go and take out all these screws willy-nilly, and we will eventually, but to get the actual board and the module out, some of them are marked with triangles like this. And if my hunch is correct, they will be ones that actually go right through and actually hold the board in. So have a look at that one. Ta-da! Yep. And what those marks show is part of the system engineering approach to this thing. The CAD designer who had to do the 3D model for this RF shield in die-cast can, machined aluminium can, then, not die-cast, I think it's machined aluminium, and they had to put these marks in, so that shows that at that stage they already knew, okay, exactly where they were, exactly where they'd go through, exactly how they'd go into the chassis and everything else. So, very nice. I know, yeah, that's probably the way to do it. These days, your CAD tools, they would have designed the whole blinking lot with all their 3D models. They would have even, used something like the Altium Designer or some other PCB package, had all the 3D model in. They would have, done all that, and yeah, it's par for the course these days. Okay, I'll shut up. And here we go. You get all the correct screws out, and hopefully it comes out. Ta-da! Oh, the BNCs at the back are a bit tricky, but voila. So look at that. Completely modular, all the functionality of this thing, all on one board, all in one big brick. Ah, beautiful. That'd be some decent cost saving on that, No multiple boards to assemble, less internal wiring, less assembly cost, everything else. So that is beautiful. And I'll tell you what, not too shabby for version 1.00. Maybe they reset it for the production version. It'd have to be. You're gonna have to respin this for R&D, surely. And my cordless screwdriver is down in the bunker, isn't it? In the middle of a much, infinitely bigger teardown than this. In fact, it's as big as one of my benches. So, yeah, here we go. Oh dear. All right, we've got one more. Come on. Ta-da! And it's going to pop out on the bottom, I think. We got it. Oh, here we go. Will it lift? There might be a gasket. No, it's going to lift straight off. We're in like Flynn. Oh, yeah, look at that. Spartan 6 FPGA, wow. And yes, we do have gaskets on the bottom. Now, I'll have to show you some sections up close, but you can see it is completely modular, as all of these things are. And at the complexity of it, you might think, well, that's kind of like the complexity of a spectrum analyzer, for example. Well, this is just a basic signal generator. Well, if you've seen my Marconi signal generator teardown, ta-da! Here is the block diagram for that, and you can see that there is a whole bunch of stuff. Reverse power protection, step attenuators, beat frequency oscillators, modulation, harmonic filters, everything. And that's what all of these, it's going to be sort of like similar. We don't exactly know how Rigol have implemented it because unfortunately Rigol don't include a nice block diagram like this in their documentation. Shame on Rigol. Come on, at least give us some technical stuff, but let's have a look at a few, just point out a few interesting things. Now here's our RF output here, and you can see this would be, as per the block diagram, this would be our reverse power protection. And you can see the signal just jumping between the shield in the die-cast can on top. And this section here, probably like the output attenuator, a multi-step attenuator, because this thing goes from plus 20 dB right down to minus 110 110 or something like 105 or something like that. So not as, it doesn't go down nearly as low as the Marconi one does, but still pretty decent though. And you might be wondering, how the hell does the signal get in or out of this block? Well, it gets out. You can see the break in the shield here, and there's AC coupled across there, but how does anything get in? Look, it's completely shielded right around here. Aha, that's when you got to go in here and have a look at some finer detail. See these little micro vias down here that go from there to there? No coincidence that they're there. They're not random. There's actually a trace inside there, controlled impedance trace going from this chip, which we'll have a close look at in a second because there's something naughty with it. And yeah, it runs inside, so it's completely shielded between the two cans. Excellent. And what have naughty Rigol gone and done? Look. Mongrels, they've lasered off these the part numbers on the chips, and they've done these to a whole bunch of chips inside these things. So they don't want us, innocent engineers, tearing down our products and trying to figure out how it works. Come on, if anyone wants to bloody well reverse engineer this thing, they can. I mean, it might slow down people for a few hours or a few days, but it's not going to stop them. Give us a break. And they've done that to this thing up here next to the Spartan 6 FPGA. And you might be wondering, what is the Spartan 6 FPGA doing in here? I thought this was like entirely analog. Well, this is the low frequency output connector here. So this is doing all the low frequency modulation and stuff like that. So they're, doing that digitally. So there's going to be a DAC in there. And that's probably what that puppy there is. It's probably a DAC. Got to have a good old-fashioned TL074 in there. Bloody ripper. So you can see that here's the output, and then we've got our output protection, we've got our output attenuator, and then we've got these 4 sections here, and these are rather interesting. Looks like, some sort of filtering. Maybe they're switching in different band filters or something like that, perhaps. And then next to that, check this out. We've got something really important in here. How do you know it's really important? Well, look at all the cutouts around it. Why have they done that? Well, they're trying to eliminate thermal expansion on whatever that puppy is there. Or there could be something on the other side. I haven't actually looked, haven't taken the die-cast can off the other side. Maybe we should do that. But yes, that little puppy there is obviously some sort of reference or something like that they're really taking care of the Tempco with. So that's nice attention to detail. You don't want any thermal expansion because, well, this whole thing's going to heat up. But then when the PCB heats up, it's got, even if it's a top quality one, you're paying for low thermal expansion board, it's still going to have some thermal expansion. So that can actually expand the pins as well on the chip, and then that can actually affect that can add stresses to the internal die, and that can affect its performance as well. So I'm a little bit surprised to actually see that in here though, but nice work. And there's the other side, and we can see something interesting down on our isolated cutout there. Got ourselves 2 big ass 150 ohm resistors. They might be in parallel for 75 ohms, and of course it's not 75 ohms impedance. What they're doing is look at the size of them. They've got to be heaters, which is heating up that particular board, so that would be controlled. So that's like a little mini oven in there. Very nice. Is that our main? That's not our main oscillator, because they've labeled that U, and that is not a oscillator package. If somebody can decode the SMD markings on that, then please do. But probably some voltage reference. But they're going to a lot of trouble. Anyway, back into the action down here. I'm not going to guess at all these components. I'm sure somebody will go to the trouble to take the photo of this. By the way, I will have high-res photos of this teardown on the board and all the sections available on EEVBlog.com, link down below. Someone usually goes along and then marks all the blocks up for us. So, yeah, I'll just crowdsource that. Bloody laser marked off the numbers again. Mongrels. And then our signal travels along. Sorry about the shaky image. I need a dolly, don't I? And then it travels along, does some more magic, heads on up here, up, up. And once again, you can see that the signal actually goes through a shielded inner layer there with a controlled impedance trace. Then back to our wider shot again, and that's our modulation input, that modulation board. And then, bingo, we've got some, what a lot of people call RF voodoo. It's just a distributed element filter. That's its official name. You can go Google that, I'm sure, and have a look. Now, it might look like magic until you actually realize what's going on here. It's basically just a filter. It's, probably just a multi-stage low-pass filter. And what we've got, these pads here, these are actually capacitors, okay? So that's effectively a capacitor going down to ground. And then these little squiggles in here, they're actually inductors. So you've got a capacitor going to ground, then an inductor in series, then a capacitor going to ground. So it's an LC filter like that. And then you would have a little bit of resistance in here due to your controlled impedance trace. And it's basically just an LC filter. That's pretty much all it is. And they're doing a similar thing down here, but there can actually be subtle differences in the geometry of these things. You'll notice this one has a capacitor going down to ground, but there's also an inductor in series, okay? And you'll see that they're different shapes. That means they're different values. And then just a tiny little bit, even that little trace connecting to that, that could be a resistor in series, tiny little bit of inductance. And there's actually, there's many different types, and I should actually have to link in some examples of these things. And you can actually see, there's little subtle differences between how you implement this. It depends on the dielectric material, the board, the type of material, the dielectric constant, and the width of the trace and the distance, all sorts of things. And there can be subtle differences. You can implement all sorts of unusual filter, bandpass, and other type of arrangements using these distributed element filters. And why do they do it? Because, hey, it's cheap and easy, and there's software programs to spit these things out. I mean, the board's not cheap. You've got to have a nice, controlled impedance, controlled dielectric board, not just your regular Joe Bloggs, FR4 from, one hung low manufacturer. They would have specifically chosen the board material exactly for their purposes. And there's advanced programs you can get to actually calculate and design all these filters for you. So there's a whole bunch of stuff going on there, and this looks like it's probably some sort of a mixer or something like that, perhaps, package. It's not the oscillator. I think I can get a part number on that. Hang on. And there you have it. That's a ZCOM 3640, the Crow series cathode ray oscilloscope. Thank you very much. It's a voltage-controlled oscillator, VCO. And right up here, next to the oven-controlled oscillator card edge connector, bingo, there is our main oscillator, 2 ppm general accuracy, but of course you plug in the oven-controlled oscillator and it's, parts per billion. And interestingly, in addition to the Spartan 6 FPGA, right near the low-frequency output here, we've got a Actel Pro ASIC 3 FPGA. So what the hell, unusual mix there. That's really bizarre. Anyway, here's some of the output protection as well. That's chock-a-block in there. Check it out. That's a laser removed the markings yet again. The mongrels. But generally speaking, on the other side of the board here, pretty much just all passives. Nothing much doing there, huge amount. So I won't go into detail. Once again, high-res photos of both sides of this board available on the website if you want to check it out. But there you go. That's what's inside an RF section. This is what you're paying for. It's all, analog RF magic. There's, these parts are very expensive. You can't skimp on, a good lot of these parts. They have to come from specific manufacturers and they cost, $50 a pop or something like that. And that's why you can't make one of these things for a couple of $100. You just can't do it. You've got to get the reputable parts. You can't just get rip-off parts from somewhere. It doesn't work. You don't get the performance. But overall, I'm quite impressed by that, because Rigol are not known for their RF stuff, but they're certainly getting into it, and this is a pretty decent implementation, a physical design implementation. Oh, in fact, it's really very nice. Shame we don't have a block diagram for it. That would have been really nice. But yeah, if you sit down for an hour or two, you might be able to figure out what all the blocks and all the parts do and things like that. But yeah, they've really gone to town. A lot of design effort is gone into this thing, and it's got reasonable specs as well. They're not gonna, they're not industry leading specs by any stretch of the imagination, but you get reasonable performance for the price, that's for sure. And the design quality, build quality, it looks like they've got someone there who knows what they're doing. Now, if you're going to buy one of these, by the way, or any similar sort of RF product like this, it's nice to do a teardown like this, but if you're after, especially if you buy a really ultra high-end spec product, you don't want to be generally taking off the RF cans, because it could actually affect, very minutely, but could actually affect the low-level performance of this thing. So it might be likely that Rigol might have to, or might, just as a matter of course, actually resend this back out for calibration once I'm done with this, taking it off, because, the torque of the screws on there and the gaskets can affect the, the shield in between sections and things like that. So, yeah, you probably, probably not on this one, but, some of the more ultra high-end ones definitely can have a real impact. And alright, why not? Because, well, we didn't see the main processor. I know there's lots of processor aficionados out there. There it is, Freescale IMX 283, one of these whiz-bang, what is it, 800 megahertz, 400 megahertz or something, application processors, high-end ARM. It's got all sorts of stuff built in. It's got all the LCD drivers. It's got everything else. There's our LCD ribbon going out there, and there's our front panel touch as well, and not much else doing. And of course we have our JTAG interface there, and I don't see usually you get like a serial debug port on these things as well, but I don't see, neither of those look like a serial debug port. So, usually you can boot these things up, hook up a, regular to a PC serial port and have a look at all the boot console information as the thing boots whatever OS it's using, but it doesn't seem to be one here. And a sneaky little 8051 in there doing something with our PCI interface, PCI connector interface, not actually PCI, standard or anything, but yeah, they're using the PCI connector, something going over to that main board. Alright, let's plug it in and see if it works. I haven't actually powered up the thing. I don't even know if it worked out of the box. I literally tore it down. Didn't turn it on, I took it apart. So let's plug it in. It takes about 50 watts, so it's a reasonably power-hungry little beast. So let's plug her in. Universal voltage, of course. Don't know what it takes on standby. I should actually test it. Hey, winner, winner, chicken dinner. Here we go. How long does it take to boot? Local boot in. Yep. Anyway, hey, we're in like Flynn. There it is. Works a treat. Beauty. Alright, let's plug it in and see if we can actually get something out of the puppy. This won't be a review or a comprehensive test at all, but look, I got a nice RF cable with it. This doesn't usually come with it, I don't believe, but yeah, it comes with its own spec sheet and everything. Beauty. And speaking of which, for all you CalCert aficionados, I know you're out there. There we go. Yes, it does come standard with a Cal certificate. Beauty. I tell you what, I don't mind the interface at all. You've got your frequency, what you want, your level, what you want. By default, it's 1 gig and minus 20 dBm. And the RF output, we can just switch off or on here, and then we can just switch our modulation off or on, and our low frequency as well. And then we can set it up, and we've got a numeric keypad, and we've got a real fair dinkum knob. So if we go up to frequency here, oh, there we go. Where's the marker? Where's the marker? Yeah, there we go, we've got a dot above it. But it wasn't obvious at first glance. It should have been, but it wasn't. Why is the dot not up there permanently? And here it is, and this will not be a performance test by any stretch of the imagination, but I'm just showing you I've got the frequency at, well, the level. Actually, I'm going to change to 0 dBm. It was -2, but there you go. It's off by about 0.92 dBm, 0.9 dBm or thereabouts. I think the spec's about half dBm. On the SIG-Gen, don't quote me on that, but then you got the scope as well. Whatever. There's our carrier. We've got a 1 gig carrier, and here, there's our 2 gig harmonic of that thing, and 2.5 as well. And that's 1 gig at -10 dBm, and let's go down lower. And that's down at -50 dBm carrier. And there's a -10 dB 1 gig carrier with some basic sine wave amplitude modulation there at, what do we got set up? 10 kilohertz, so easy peasy. And if I change the depth down to 1% there on our modulation, bingo, it all works. So I didn't break anything, that's the main thing. Might have whacked it out of cow a little bit, half a bee's dick. So yeah, you got a whole bunch of modulation there, AM, FM pulse modulation, and there's options for that. We can do sweeps as well, that's very nice. And well, we've got our level and our frequency. It's all very nice to use. Turn your modulation off and on, turn your RF off and on. Beauty, Bob's your uncle. What more do you want? So there you go. I hope you enjoyed a look inside this Rigol DSG815. And apart from the caps on caps, it's a pretty decent design and build quality, it looks like. So definitely a thumbs up to that, apart from the caps, which is a thumbs down. But yeah, you know, it's par for the course these days. But yeah, when you're paying $2,000 for, you know, a SIG-Gen like this, you know, you expect Nichicon or some other, you know, Panasonic, some quality caps in there at least. Come on. Don't skimp. I know you probably bought them caps on ones by the zillion, and people are going to say, why harp on about the caps? I don't know. This is the only thing I really found wrong with inside the thing. It really is quite nice. So I haven't actually compared the specs on this thing compared to others on the market. Bang per buck, I don't know yet. I haven't investigated. This is not a review. This was just a teardown. And I hope you enjoyed it. If you did, please give it a big thumbs up and discuss it in the comments and links. And as I said before, high-res teardown photos on EEVBlog.com, linked in down below, unless you're already watching this video on EEVBlog.com, in which case you already know the links are there. Catch you next time.